All right, let's see if we can do this. I'm gonna wait 4 or 5 minutes and see if anybody shows up. I don't know if anybody will, but this is more of a test drive than anything. So see how this goes. All right. So I guess the thing that I'm passing on some knowledge here, or gonna see what if anybody wants to learn how to do this. But this course is, or I don't know, course. This little, it might turn into a 3 or 4 day thing. I don't know where I'm going with this, but I'm gonna try and throw out there how to review WPSs, PQRs, and welding documents. Just the review. I'm not going to get bogged down into how to write them and all that stuff. I'm just going to kind of, if you're a welding inspector, a civil engineer, or something like that, and you have to review welding documents and you've never dealt with them, well, this is kind of going to be the crash course on how I do it. And I've spent, I don't know, 10 or so years just doing specifically that, and been doing it writing WPSs to Asme Section 9 and other codes for the last 10 years or 25 years or so. So I'm just kind of talking here. I'm going to get into this here in about 4 or 5 minutes and see if there's 4 people, I guess, right now. So if you have any questions, you can, I guess, text me. I'm kind of looking at those, but I'm going to cycle through these slides here and see how this goes. All right, so how to review welding documents. First, the objective, we're going to take a look at the review form. We're going to take a look at the review form that I used to provide. It's when, all right, I'm kind of dealing with software. Okay, so I'm going to take a look at, we're going to talk about the review form that I use to provide feedback to the submitting party. So if you submit a WPS for review and I'm the guy reviewing it, I usually give you a feedback form. And we're going to go through this. So if you're a structural engineer or a civil engineer or a CWI, and you have to review welding documentation, this is probably one of the better ways to do this is with a form, and to give your people, whoever the reviewing party is, some or the person that submitted the document, some feedback. So here's my theory on reviewing documents. Be polite when possible. You don't know who's on the other end of what you're reviewing. So be polite. It doesn't hurt, because things can escalate, and I've been in enough of these fecal matter throwing contests between different engineers and different outfits so that you can you kind of end up knowing it's coming, so there's going to be an argument. So just keep it polite until it isn't. Remember, the person submitting the WPS and PQR for review might not be as experienced as you are. And these reviews sometimes turn into a situation where you're instructing a person on how to write a WPS or a PQR. A lot of times I've had to do that, where it was a situation where the person writing the WPS or PQR wasn't very knowledgeable on welding or welding codes. So I would end up, using this as a tool to help get my vendors up to speed. So a lot of times you could pass on some good information using this form. And sometimes when you're submitting you might not know as much as the person submitting the document. So, it could get ugly. You could end up in a, going back and forth. So before we get into this too far, I'm going to talk about shall, should, and may. These are the AWS definitions. Shall, should, and may. So when you're reading the code and you're telling somebody what they need to do when they're reviewing when you're reviewing their WPS and you're quoting scripture to them, you need to understand shall, should, and may. These are the words that any WPS or PQR review is built on: shall, should, and may. So we need to keep that in mind as we go to the next couple slides. I've got this broken down. Shall. Shall is mandatory. Shall doesn't give you any options. Shall is you're going to do this. There's no options. Shall is, this is from AWSD 1.1, 1.711. Code provisions that use shall are mandatory unless specifically modified in contract documents by the engineer. Shall. Shall. You shall do it. It's not an option. If it says you shall do it, you shall do it. If the code says you shall weld this standing on your head drinking a Diet Coke, you will weld it standing on your head drinking a Diet Coke. That's the game. Should. Let's move on into should. There's a little lag here, so I don't know how I'm doing. Should. Should means that's a good idea. Should means this is setting you up for the best possible outcome. This is a really good idea. When the code says should, unless you got a really defendable, better way to do things, should is probably the best way to go about things. If it says you should drink a Diet Coke and stand on your head while welding this, that's not a bad idea. Go with that. Unless you've got a better proven method that you can defend to the engineers and inspectors and whoever else. Should is used recommended practices that are considered beneficial but are not requirements. Should means that this is a good idea, but if you can't do it, and you have a better option, you can go in that direction. And if you're going to go against something that's a should, you should be able to defend it. Should is also setting you up for success. It's a best practice. Should. May. There's kind of some lag on this computer, so. May. May is optional. This is another one. 1.7.13, may. The word may in a provision allows the use of optional procedures or practices that can be used as an alternative or support to or supplement to code requirements. These optional procedures that require the engineer's approval shall be either specified in the contract documents or require the engineer's approval. The contractor may use any option without the engineer's approval when the code does not specify that the engineer's approval shall be required. So, may, it's you got a lot of different options. You may do this or you may do that. It's a big difference from should and shall. May, it's wide open. You may do this. So these are the three key words as you're going in if you're going to do any kind of code work. May, should, and shall. You got to understand these if you're going to be reviewing welding documentation and marking up other people's stuff. Okay, so let's get back to my review form. So this is what my review form looks like. I don't know where I found it, but generally when I used to be a civil engineer, so generally when you're doing civil engineering and you submit something to the city or the county, they kick it back with a form like this. So I don't know if I snagged this from somebody else or I just put this together, but I probably stole it from somebody, whatever. But this is how I do it. I stole somebody else's good idea. So this is how you review a form. This is the form I use. So I just put on the top, it's got the PO number, the date, the supplier, references. When I use the references, it's the it's what code I'm working to. Any other text specifications, address it to who I'm sending it to, from, me. And if it's depending on what it's on, is there a part number? Is there a PO number? What do we got going on here? So I try and get as much information so then when whoever submitted the document gets angry at me and sends it back, I can defend myself and say, oh yeah, that's this form. This is why I did this. And the nice thing about a form is if you're doing the same code and you're reviewing these documents, people generally screw up the same things on these codes. So you do one and you find all the other stuff. So that's what I do have in the top side of this form. Here's the list of documents that were reviewed. I put that right there. Welding procedure, blah, blah, blah. The second document, procedure the PQR that goes with that document. So that's how I do it. So, I reviewed these documents, boom, 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 and this is what happened. All right, so then this box is the recommended document status. Is it accepted? Is it accepted with comments? Not accepted? In different places I've worked have had different ways to disposition documents that are submitted. So that's how I, do these ones. So recommended document status is it gets its own box. Oh, we got 2 viewers. Marvelous. It's just probably 2 more than I thought I was going to get. Oh, we're up to 3. All right. Back to, okay, so here's where I generally put general comments. Especially if it's somebody that I don't think knows very much about the code. And so I put general comments in here. So like in this one, it's, it tells what the contents of the WPS are. The completed WPS shall describe all essential, non-essential, and when required, supplementary essential variables. So if I'm whacking somebody on this and telling them they need to address non-essential variables, well, here it is. Boom. This is the part of the code that says you need to do that. So I generally put, relevant portions of the code that kind of tell people what they need to be doing. I throw those right in there. So, and I reference key parts of the code right off the start in that one block that I was just discussing. And I use it as a teaching experience for maybe individuals that are not as experienced as I am in the code. So it just kind of throws it out there. It's like, oh, we all know this, this part of the code, we all know this. And you're kind of throwing it out there, but you're not really hammering them with it. And that's kind of my method. It shows them in print too, that and I like to give people chapter and verse. You need to address this, 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 and this. So, telling them what they need to address and what corrections or what they need to address, what kind of variables. So, some other key parts of the code that I throw in there, depending on what I'm reviewing, is the contents of the PQR. This is out of Asme Section 9. It tells them everything that needs to be addressed in the PQR. So I throw that out there in general. All right, you need to address this, 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 and this. So that's one of the key parts of the code that I throw out there just as a kind of a learning type experience. I don't know, gives them something, so it doesn't just throw it at them. It throws it at them, but doesn't just beat them over the head with it. Or maybe it does, I don't know. Another key part of the code that I throw in there is, the contents of the WPS, and the WPS shall reference supporting procedure qualification records. I throw some of this stuff in there also. And I also put in, okay, so we're back to the reviewing form. So I just got done talking about, some of the key parts of the code that I throw in there just as a opening salvo or an opening volley, a shot across the bow. Okay, you guys need to do this. And then I get to the required changes. This is the items that they need to fix. This is the shall stuff. You shall do this. First time I reviewed a WPS, I went through it with a freaking red pen and marked up all kinds of stuff. And my boss at the time, real good guy, Dave Shaver, he's like, pace, whoa, pump the brakes, dude. They're going to hit us for change orders if you want. And I was like, this is a garbage WPS. He's like, read the code. Check only essential and non-essential variables. That's the only thing we can get them to fix. They need to address all essential and non-essential variables. So when I write things up, this is how I do it. I just, please address QW 40211, the addition or deletion of non-metallic retainers or non-fusing metal retainers. Boom. And I just go down, if I'm doing, this one's to Asme section 9, but I just go down chapter and verse and just copy that section out of the code, the things that they need to address. So I just kind of go through them, boom, boom, boom. All right, here you go. This is what you need. And and I address it like that. And, please, please, please. They know they got to fix it. But if you only put things in there that they have to fix. So it's essential, non-essential, and or supplementary essential variables. You can't, one of the first ones I did, I just went berserk on it. And my boss, like I said, old Dave said, no, Pace, pump the brakes. You can't be doing it like that, or they're going to whack us with a bunch of change orders. So here's one of the recommended changes. If you got something that just bugs the hell out of you, or you don't think that they're, this is stuff that it might not be a bad idea to fix or clean up. Hey, this is stuff that is just, I've never seen it like this, blah, blah, blah. And you throw it out there and it's, formatting issues, spelling errors. It doesn't make sense. Maybe they got some craziness in there. Maybe you want them to make it a little less convoluted. You can, this is suggested, recommended changes. And these are things that could be fixed, but don't need to be fixed. So, it's just a wish list. And I think generally most people, most of the time I've helped somebody, giving them some feedback on their stuff, especially if they're a smaller shop. Most people are generally, if you put it in the right way and don't just go through their stuff and tell them everything's garbage, it generally is taken pretty well. So that's kind of how I do it. And another thing you can use when you're reviewing is so code interpretations, code cases, and code interpretations. Code interpretations is like sending something to the Supreme Court. All right, we got this law. Well, we think it's this way. We think it's this way. All right, okay, let's, So somebody types it up, they write it up, they submit it to the code committee. I throw these in sometimes when people are giving me flack on, how they should address or not address essential and non-essential variables if it gets push comes to shove. So code cases, interpretations, sometimes I'll copy those in and, throw them in as comments. All right, you didn't believe me. Here's where it says you have to do this. But like I said, this is when there's a question and somebody wants clarification of the code and how it pertains to certain situations. So say they submit a code case and the code committee reviews it, and if they think it needs clarification, they'll address it, kind of like the Supreme Court or something. So that's what kind of how I review WPSs, or at least that's the form. That's the form I use. Anybody's got any question? Whoa, that was kind of weird. So if you got any questions, comments, thoughts, concerns, you can contact me at gpacex@gmail.com. I usually answer, welding related questions. So I'm gonna probably go through another how to review. Let's while I'm here talking. This is kind of a test run for some of this stuff. I'm gonna go into the how to review a PQR. So see if this. I'm probably going to do this at a later date. This is kind of a test run, kind of like a stand-up comedian before they go on tour. They go and work out their material at a small club. So we're going to talk about how to review a PQR here for a minute. I don't know how far I'll get into this before I pull the plug, but I'll make it. We're going to try and talk about how to review a WPS and PQR and welder qualification records. I plan on kind of grinding through some of this stuff, and we'll discuss it. So for the preview, we're going to just get to a general methodology. I'm going to give you my general methodology. Like I said, I sat in a cube for years reviewing WPSs and PQRs and welder qualifications. So I'm not saying I'm the end-all be-all of this sport, but I've done it for years for a couple of really big corporations that do heavy construction and whatnot, and I've done a lot of it. So I'm kind of an expert. I might not be the world champion, but I might not be in the major leagues of this in a sport, but I'm probably a AA player, maybe triple. But anyways, okay, so we're going to talk about how to review a WPS. And the first thing we got to do is, are we using the correct code? We're going to talk about, some other documents that go with a PQR that we need to look at. So, like I said, I'm kind of working through this too. Whoa, that didn't go good. Let me get to my slideshow and kill all these. Clear narration on all slides. All right, there we go. See, like I said, we're working through this. So, my apologies to the 5 of you that are out there listening. Okay, so we're going to talk about codes here for a minute. You got to have the correct code. How do we skip that? All right, there we go. So a procedure qualification record it's the record. Before we can talk about this, we really got to talk about what a procedure qualification record is, a PQR, so that we know what we're getting into when we're reviewing a PQR. So if you're a civil engineer or a whatever, mechanical, or a newly minted CWI, and somebody tells you to review the WPS and PQR, you should probably kind of know what you're looking at, or what the document is and why you're looking at it, or what should be on it. I had a buddy of mine years ago. He was a structural guy, and he reviewed something, and then I kind of followed up, and I was like, what were you doing? He's like, I don't know, I was fresh out of school. So anyways, a PQR is the record of the test that is then subjected to a number of destructive and non-destructive tests. We're going to weld metal A to metal B with some filler metal, and then we're going to do some bend tests, some tensile tests, and maybe some impact testing. And the PQR is going to contain the parameters that we used while we were performing that test weld. The documents and the destructive and non-destructive testing result. So we're going to have our lab results stapled to this, or electronically stapled. And then after it has been determined that the test weld for which the PQR is written is sufficient, the WPS provides the welder with the information necessary to produce the results. So the WPS is a recipe card, On one of my videos, somebody told me I was a little redundant, but all right. So a WPS is just a recipe card. It's just telling us what goes into the chocolate chip cookies. Each chocolate chip cookie gets this, or each weld gets this, and this much post-weld heat treat. That's what a WPS is. And a PQR supports a WPS. So as I'm going through this, I'm kind of talking, because there's two things when we review these documents. Chicken, egg, they're going to be submitted together, so you're going to end up having to kind of look at them together but separate. So I just went with the PQR. We'll do that one first, but it kind of ties back to the WPS. So it's kind of a convoluted how you review these things, but anyways, a WPS is a recipe card. If it says to stand on your head, drink a Diet Coke while you're welding, you better be doing that when that inspector comes through. So another thing is with format. Don't freak out if it's in a weird format. The code doesn't require a specific format. The code requires, they give you a recommended format, and that's what I've shown here. This is pulled out of Asme Section 9. And it says format of the PQR form, blah, 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 has been provided as a guide for the PQR. The information required to be in the PQR may be in any format to fit the needs of each organization, as long as every essential and, when required, supplementary essential variable required by QW250 is included. Also, the type of tests, number of tests, and test results shall be listed in the PQR. So that tells you, on your PQR, you need these variables, you need all the essential variables, and if there's impact testing, you need supplementary essential variables, and on the last page, you're going to throw in the number of tests and the test results shall be listed. A while back, I reviewed a WPS, and then I got the PQR that was supposed to support the WPS, and there was no testing result. And I'm like, who the hell wrote this thing? 20 years of reviewing these things. This is just some of the worst I've ever seen. So anyways, on the format, if somebody sends you a format you've never seen, don't flip out. As long as they address all the essential and, when necessary, supplementary essential variables, and they give you all the testing data, you're good. So, there's different formats here. I used to work for a place out on the West Coast, and they, had everything written in paragraph form. Everything was addressed, but it just wasn't in this suggested format that's in the welding code. Everything was written down. So, these things, like I said, with the format, don't freak out. So when we're going into WPSs, just remember that a WPS can be edited and revised just as long as there isn't any changes. But a PQR can't. An example of a non-essential variable that you could change on a WPS would be something like cleaning. I can do cleaning on, on my next revision, I only want stainless steel wire brushes to be used. Well, that's not going to change the mechanical properties of my welds. But, if I change the filler metal from carbon steel to stainless steel, that's an essential variable I got to requalify. Okay, so a PQR is a living document. Okay, we're going to talk about what a PQR is. A PQR is not a living document. It's like a birth certificate. A PQR is like It's like a birth certificate. Other documents are built on the PQR, kind of like a passport. You can't just go get a passport. That would be like having a WPS. Just make a WPS. You can do that with some codes, but for the most part, you need a PQR to support it. That's what a PQR is it's a supporting document. It says that we welded cardboard to plywood using bubble gum. We did some tensils, some bends, and impacts. This was our testing data. Everything's good. We'll write our WPS to be able to weld those materials together using that filler material. PQRs are not a living document. Do not update these things or revise them. Changes are permitted, but you gotta, it's gotta be corrections, or maybe a variable was incorrect, or editorial corrections, stuff like that. But for the most part, PQRs, you don't mess with them. If you need to change something major on the PQR, it might not be a bad idea to just do another PQR. Best way to go about it is just to do an addendum or an appendix to a PQR. You know, if you got to change something, just do an addendum, staple it all together, explain what's going on. This can be due to a code change. Let's say your code, your welding code was, what am I thinking? Let's say your welding code, your material. Let's go to P5C materials. P5C materials are codes that were steels that were used in power piping, steam piping. So there's 5C is one of the P numbers. Well, there got to be so many of them, and the chemistry's got to be so weird with, you know, that they split them out and made like a whole other category. So if you got a PQR that was written in 1980 before they split P5C into P15E or whatever those are, with the creep resistance enhanced ferritics, I think it's P91 materials and stuff. So when they split all those off, well, maybe your old PQR has that material, but it says a 5C, not a P15E. So a lot of times these things change. So if something in the code changes that it affects how your material was classified, type up an addendum. You don't go redo the PQR. Just type up an addendum that says, hey, this is what happened. Code change, 1997. This code went, this filler material or base metal material went from being a P8 material to a P27 or whatever the number is. Additional data may be incorporated in the PQR provided that the information is substantiated as having been part of the original qualification condition by lab record or similar data. So if there's something else that needs to be incorporated into that PQR, you could do it. Or if you had additional, let's say you ran a really big test coupon and you had material left over and you needed to do, let's say, heat treatment or impact testing, that might be a situation where it makes sense to include that data. If you have the original test material, some material from the original test. So that might not be a bad way that you could change the PQR. But generally you don't change PQRs. It's just better to rewrite them. If the company name changes, all right, so then you gotta address that. You know, you're gonna include a letter for the name change as a cover page for the PQR, or you could transfer all the PQR information to a form with the new company name, including a letter explaining the reason for the name change, and attach all that documentation, including the old PQR. For a new form, transfer all the PQ information to the new form and attach all the existing documentation, including the old PQR. So that's what you know, if you're going to change a PQR. Okay, so now that we know what a WPS and a PQR is, let's talk about our general methodology on how we're on reviewing this stuff. So when reviewing a PQR to support a WPS, the following is my general methodology. I'm going to find out what code I'm working to. what are we doing? Are we doing piping? Are we doing structural? Are we doing something else? What code are we working for? That's where I generally start. Are there any additional requirements that are imposed by the customer? I'm down here in Houston. A lot of times there's customers that Shell Oil or some of the offshore giants, they have very specific customer requirements or requirements for their projects, especially when you're dealing with duplex stainless steels or some of this stuff that goes on subsea. They've got very specific requirements. So in addition to the code, you're going to also be reviewing, with the customer requirements. Then you're going to look at the welding process is what I always look at. Okay, what's our process? What do we got going on here? Make sure the base material matches the code. I always check this out. Make sure the base material matches the code. Sometimes engineers will call out the wrong welding code. I was doing hydraulic cylinders, one of my first jobs, and our client called out AWS D1.1 for hydraulic cylinders. Well, it doesn't really fit. Hydraulic cylinders, D11 is for, buildings. Structural steel, it doesn't fall into hydraulic cylinders. So I tried to explain to him that to a lot of people, it's just there's a welding code. It's like the Bible or, some other holy book. Everything's contained in D11. It's the welding code. There's no other documentation. That's it. Done. So, make sure that, the base material matches up with your code. Or somebody wanting to weld stainless steel with D1.1, maybe you should tell that engineer, the design engineer, that there's a better code and they should probably use D16. So you got to make sure you got the right code. So then after you've looked at the WPS and found out what process you're using, you need to delve into the code to review the essential and non-essential variables you need to address. For Asme, this is going to be in tables QW253. There's a bunch of them. Each welding process has a table with all these essential and non-essential variables. D11 has its own set of essential variables, and that's in table 6.5 of D11, the 2020 version. And then other codes are going to have similar tables and requirements. Also, just because something's an essential variable in one code doesn't mean that it's an essential variable in all codes. You got, D11, there's some things that are going to be similar between D11 and D16 or D11 and ASME Section 9, but not everything's the same. Everything doesn't carry over. So you need to be cognizant of this when you're doing your review. Oh, we're up to 10 viewers. Nice. I guess. No. So now you have to we're still going through our general methodology, how I approach this. Somebody throws a stack of these on your desk. Well, now it's usually email. So, but look at the PQR supporting documents and make sure everything matches up. Make sure all your lab reports are there, material test reports, COCs for filler material if they're required, base material certifications, correct number of bend and tensile tests. Make sure those have been done. And was impact testing required? I've gotten into a fecal matter throwing contest a couple times over impact testing. We had a WPS that had impact testing, but for that project, impact testing wasn't required. And the inspector tried to make it an issue, and it's like, no, this isn't an issue. So for the quick check, I don't know why I got that down there, but, make sure it's the correct company. Check your company. Make sure you got the correct WPS and PQR and the company. Make sure your WPS and PQR your supporting PQRs are there. Correct code, welding process, and base metals. Make sure everything kind of matches up, that they didn't get crazy with this. I got to make sure I cleared all these. Oh yeah, so all my narrations should be cleared. So, oh, all right, whatever. All right, we're back to where we were. Sorry for the technical difficulties. So I always do a quick check, make sure this stuff makes sense. And then the other thing I try... sorry. Well, maybe we'll do it like this. We'll just run off of this one. I hope everybody can see that. Also make sure that the code matches the work being done. Make sure the... Oh, hey, everybody. Hey, thanks, Aaron. Appreciate that. Donnie, Robert. Does the code match and on the WPS match the work you're going to do? Did you submit the right code? Make sure that they didn't submit a structural WPS for a WPS or for work that's going to be, piping or something, or section 9 for whatever. So just make sure that everything's, kind of makes sense and is in the same, ball game. Well, here I've got a, section welding procedure for section 9, and my drawings match up, and we got, what looks to be, piping and some pressure vessels and whatnot going on. But here we've got, AWS D1.1 on the welding code and on our welding procedure. And then, they're wanting to do some piping and some, small pressure vessels or whatever. So that's generally not the direction to go. You want to make sure the supporting PQR matches. So you want to find that number. That's one of the first things you need to look at, when you're doing these reviews. So you want to make sure your PQRs match up. That they've submitted the right PQR for that WPS. Generally they do, but sometimes people submit it no. So here's the typical completed PQR contents. PQR, you're going to have the essential variables, but sometimes they'll include non-essential information. It's not a crime if they do. They don't have to. And then, you have a bead placement sketch. Sometimes you'll have non-destructive test results, destructive test results, base material MTRs, filler metal MTRs, and any other pertinent information. This is what's going to go into a PQR. So, here's a typical one. I kind of circled, like your base metals here. And your essential variables are going to get listed on this. And once again, you don't have to use this as a PQR. As the, the form. But this is what one looks like. And, you just go through on QW253, and this is where all your information is going to be listed. Here's where you're going to put they're going to put their tensile tests and their bend tests and toughness tests and stuff like that. So, just kind of gives you a general idea of, what this is going to look like. The one I reviewed a few weeks back, it didn't have any of this information. And remember, the code says you shall include this information. And then we've got, our mechanical tests. This information would be listed in, these boxes. So when we do our mechanical testing, that's what's going to go in there. So let's see. So here's some examples of some variables that you're going to want to look at and review. If you're reviewing a lot of these documents, you're going to want to make sure that your documents, have all the essential variables listed. And one of them is, did they do enough bend testing? Okay, they did the thickness, and how many bend tests did they do? Okay, so they could do, 2 tensils and 2 face bends and 2 root bends. Did they get the right amount of testing done? So that's one of the essential variables you're going to want to really look at and make sure that, all that information is included on your PQR. And this is what the essential variable tables look like for ASME Section 9. So here's what your essential variables would look like. You just go down, if you're reviewing a PQR, you just make sure that they've addressed all these essential variables. So you just, anything that's got a box, they've got to have had to have addressed it on that PQR. So you just go down through there and check them and see what they've missed. And you go back to your review form. Remember I talked about our review form? You go back to your review form and you add the questions, or, tell them the things that they need to review. All right, please address this, 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 and this. So, supplementary essential variables. These are variables that are when you have impact testing. If there's a material if there's somebody that's going to, if we're building something down here in Houston and we're sending it up to, northern Canada, up to the tar sands, well, then we want to make sure that we address the supplementary essential variables. Quick shot into the world of Sharpie V-notch. When they talk about impact testing, this is what they're talking about. We're going to make a little notched specimen out of our weld test coupon, and then we're going to hit it with a hammer here, and then it's going to tell us on this scale how much energy this little piece of material absorbed when that hammer hit it. And this is due to a ductile to brittle transition temperature, without going off into too much of a deep dive into metallurgy. I got one more metallurgy slide and then you guys are off the hook. So the amount of energy that's absorbed is on this y-axis, and the x-axis is the test temperature. So a lot of materials, as they get colder, they go through this. You can see it's like an S curve here. And steels will go through this. The colder it gets, the less energy they're going to be able to absorb. And that's why a lot of materials, when you send them up to the North Slope or up into northern Canada, just can't take much abuse. Here's another example. And this generally only happens with body-centered cubic materials like carbon steels. So sometimes you got to throw some nickel or other alloying elements into the steel to get it to be able to take the abuse. And it stretches this, it moves this curve to the left so that the impact energy at certain temperatures is higher than it is with an unalloyed material. So that's what we're talking about, when we're talking about impact testing and supplementary essential variables. I didn't want to get off too far into the to the ether on that one. So, we've got some Asme variables here. This is another one. This is for oxy-gas welding. The big ones are like P numbers, F numbers, A numbers, classifications. These are pretty standard across most welding processes. And each welding process has its own table. And what might be an essential variable for one process might not be an essential variable for another process. So this is all the stuff that's in QW 400. Without getting too much into how Section 9's laid out, if you ever have to go into Section 9, and it sends you, and Section 9 is laid out with QW 100, which is like all the general rules. QW 200 is procedure qualification. QW 300 is welder qualification. And QW 400 is like, I don't know, it's like a library or a swap meet or something. Don't go into QW 400 unless you absolutely have to. Unless something sends you there, you go and you get out. You don't go in there and wander around and read, this doesn't read like a book. QW 400 is just a library. You just go in, get something, and you get out. That's all you do. That's the way the game's played there. So you just got to get in, get out. That I could go on a whole rant for that one. But so in QW 400, it's got all these little paragraphs, I guess, or little snippets. These are the ones that I copy over to my review form. Please address QW 402.11, addition or deletion of non-metallic retainers or non-fusing metal retainers. That's where I do them. I just copy them out of there. Go into the code, copy them out. But back to the general thing, be careful when you're going into QW 400. So also in QW 400, there's another thing that we need to know about. P numbers. It's base metal groupings. P numbers are numbers that are, so when the code was written, they wrote it and then they figured out, oh man, we got all these metals. Well, we should probably, to keep the number of welder qualifications down and procedure qualifications down, let's get some groupings of these materials. So all this stuff is kind of similar. All this stuff is kind of similar. The carbon steels, let's group them all together. So P1 is your basic garden variety carbon steels. Aluminums are P21 through 26. P1 through P15. F is, your ferrous alloys, steels and stainless steels and all those iron stuff. There is no P2 because they don't use it. It used to be for, what do you call it? Not ductile iron, wrought iron. Stuff that the, the Eiffel Tower's made out of. So anyways, you got copper and nickel. Those are the 30s is copper. Nickel alloys are the 40s. Titanium's the 50s. And Zirc is the, the 60s. So in Section 9, this is one of the things you need to look at when you're reviewing your WPS. This is an essential number or an essential variable that you're going to have to look at. But you have to look at, when you're looking at P numbers, well, there's whole tables of these in Asme Section 9. So P numbers are an essential variable. And you're also going to have to look and see if the tensile strength of your tensile tests hit the minimum for that material. So all the tensile strengths are listed in here for the different types of material. So if they used an SA 249 type 310 with columbium, this UNS number, it's got this tensile strength. All right, my tensile test broke at 85. I'm good. But if they submit a tensile test that broke at 60, now something went wrong there. So you need to, understand how this table works if you're reviewing and or writing WPSs and PQRs. This is some slides I had and a couple other things, but it ties in. So here's an example of P numbers and how they work. So So if I used a P1 to a P1 with 7018, then we can weld any P1 to P1 material with, 7018 or any other F4 material. I don't know. And then here's another example. Would be like welding stainless steel to carbon steel and using a stick electrode, shielded metal arc electrode that's stainless steel. Then we could weld any P1 to any P8 using any F5 material. So this comes into play. You're probably wondering, how does this come into play? It comes into play because you can qualify a welding procedure with P numbers, specific material numbers, but it gives you a whole wide variety of other things you could do on the WPS depending on how you write things. So, I know I say a lot, sorry. So here's examples of F numbers. Here's examples of F numbers. And these are like, this would be F4 materials, which are like 7018 and whatnot. I'm only going to do a few more of these slides. I'm going to finish this off. I got about 15 slides to go. So, So let's talk about A numbers. This is another one you're going to see as an essential variable, and it's going to show up on a WPS and on a PQR. So an A number is a chemical composition of the filler material in the as welded condition. The A number is an essential variable in most welding processes. A numbers are for ferrous materials. A numbers do not refer to the filler metal or electrode composition. It refers to the deposited weld metal chemical composition. Sorry, I got the dog in here and he's going nuts. The filler metal and deposited weld metal have different chemical compositions. So here's the table where you'd look at A numbers. So this is another thing you need to look at when you're looking at your WPS and PQRs. And you're going to have to throw it in there. Where's my PQR here? So, there's a spot on here for base metals and then filler materials. So, F numbers and A numbers. These are essential variables for most welding processes. So this is something that needs to be addressed. And you should understand, if you're reviewing this stuff, you need to understand, P numbers. I'll have to explain group numbers at a different time. Trying not to get into too many, down too many rabbit holes. But A numbers it's the chemical composition for ferrous materials. So like A number 1 is for mild steels, carbon steels. And it tells you what, it's got to have a, maximum of 0.2 carbon, 0.16 manganese and 1.6 manganese and 1.0 silicon. And then the next one I got circled there in red is, A2. It's carbon steel molybdenum. It's got a lot more moly in it and whatnot. And then you get down to 8, you got, your stainless steels, your austenitic stainless steels, onward and onward. So this is only for iron-based materials. Aluminum, nickel, titanium, they don't have A numbers. Copper doesn't have A numbers. It's just ferrous materials. But you need to understand how this works, because maybe somebody will slip in a filler material and they say it's an A1 and it's not an A1. It's an A4. It's an essential variable. All right, you got it wrong. You need to check this. So if you're going to be reviewing, you kind of have to understand how, A numbers work. I don't know if I'm explaining this very well, but I'm trying. Okay, we're going to switch over to AWS, some AWS variables here that you have to look at. Okay, so AWS, ASME Section 9, they don't care about positions. If I qualify a weld procedure in the flat position, They don't care if I weld on the roof or sideways or upside down, whatever. I qualified it. It's up to me to figure it out. Well, AWS D1.1, and D16 and those codes, they take into account the position you're going to be welding in as far as procedure qualification goes. So when I qualify, you need to understand table 6.1 and how it functions, because, okay, they qualified a weld procedure in the flat position, and now they're wanting to use that procedure to weld uphill. Nope, wrong answer, guys. You didn't qualify it in the right position. So you need to show me that, you can weld uphill. Qualify me a procedure for that position that you're going to be welding in. So that's something that one of the subtle differences between AWS and ASME Section 9. And here's a similar table to what we looked at. This is a table that's telling you, okay, on my WPS qualification, how many side bends do I need to do for, a certain thickness of material. And then it's going to tell me my thickness qualified. So this is another one, if you're going to be reviewing, you got to be able to run through these tables. I got to work on that. So here's qualification of fillet welds. I'm not really going to delve into that too deeply. Here's the big table for AWS variables, is table 6.5. This is the essential variables that require changes requiring WPS requalification for SMAW, SAW, GMAW, flux core, and gas tungsten arc welding. And you can go down through this. Generally, when somebody needs to fix something if I'm reviewing the AWS D1.1, I just go to this table and chew through it and, all right, fix this, address this, address this. You can see in these tables, too, that they don't have, if it's grayed out, you don't have to address it for that process. Here's some more off of that table. Changing, the amperage for each diameter used by, a certain process. So shielded metal arc, it gives you a pretty wide degree of latitude in regards to how you're going to, your voltage, your amperage that you're going to use. Other processes, with the amperage, it's gonna tell you. But understanding how to navigate table 6.5 is important. Table 6.7, if you get thrown into supplementary essential variables, take a look at 6.7. And another one is to just kind of wrapping this up. Like I said, this was kind of a test drive for this presentation. I'll probably do it again, maybe a more grown-up manner, after I've kind of walked through it and saw my slides and things that I need to fix. But make sure your tests have passed on the tests have passed, and all that information is on your PQRs. Just make sure all that information is included on your PQR, and then as you're going through all this, you're going to go over to your review form and type all this in. Okay, I'm going to read some of the comments here. I'd love to see you make a video about AWS D1.1 WPS qualification with base metals that come in round bar. To regular shape like plate, used in structural steel, AWS Group 2. I actually have had a round bar melted and rolled into plate to qualify such a WPS, since D11 only has plate and tube coupons for WPS qualifications. Yeah, I don't know. I'm going to have to think about that one. So, all right, did anybody get anything? Did anybody get anything out of this thing? My hour of ranting here. I got to cut it off and go eat. Plus, I finished up pretty much what I needed to clean up, but all right, I'm gonna get out of this. If anybody wants to contact me, where's my contact info? You know, I can be reached at gpacex@gmail.com. I'll probably do this again. I'm going to do another one on welder qualifications, and then kind of the matching one of how to review a WPS, or maybe even a PQR, a pre-qualified PQR. So I'm going to probably do a couple more of these if people find them of value and whatnot. So anyways, if you have any questions, gpacex@gmail.com, or TexasWeldingEngineering.com is my website. If you think this was worth anything, I got a PayPal donation on there. If this helped you out and you want to buy me a cup of coffee, I do take donations. So anyways, lob me an email if you got something you'd like me to rant about, and we'll see if we can do it. All right, everybody, take care, and I will talk at y'all later.